if I gave you a graph like this, oh my gosh, the struggle is real. If I gave you a graph like this, and this was my original,
Yes.
is this an absolute max?
No, it's a local max.
It's a local max. What about this one?
Absolutely not.
Local. Right? Okay, what about if I restrict the domain? So say I give you something like this instead. What is this?
Local max.
This is a local max. What's this?
Absolute min.
Absolute min. Now this is what I need you guys to know. So they're local or absolute, right? Local mins cover all the mins. Absolutes are just a very specific min or max. They're like the lowest or highest. Endpoints, restricted domains, like the endpoints, can't be local. They can either be absolute, the highest or the absolute lowest we go, or just an endpoint. Okay? So what would this one be?
Endpoint.
An endpoint. What would this one be?
Absolute.
Absolute max. So these are still maxes and mins, the actual maxes and mins. This endpoint's an absolute max, that one's just an endpoint. Endpoints can't be local. Okay? Make sense? So if I gave you something like this then, got a little draw happy there. All right. What are my endpoints?
Nothing. Here, just endpoint.
They're just endpoints. What's this?
Absolute max.
What's this?
Absolute min.
Okay. So today we're going to talk about max, mins with restricted domains.
Okay.
And we're going to do the second derivative, so concavity.
Short form maximum.
I know, so I can do what I want.
No, that's just what we
On a test, I wouldn't.
So why
But in my notes,
Yeah, why you?
I never looked at one thing. Practice like
That's
you
lazy.
guys.
This is left. That's lazy.
I'm going through your guys' notes and checking on all of them.
No, I literally.
Yeah.
When I read through my notes and I see max min.
So we have f of x equals 12 plus 4x minus x squared. Okay, that's what we did yesterday. Then today, the difference is I'm going to add 0, 5 as my restricted domain. We agree?
Sure.
So I want to know the absolute max and mins. So I'm still going to have to go look for my critical numbers to get my max and mins, yes?
Yeah.
Then I'm going to have to take my endpoints and those two critical numbers and find all the y values, correct? In order to figure out which is the highest and which is the actual lowest. Okay?
Makes sense.
So let's go through and let's try this out. So f prime of x equals 4 minus 2x. And in order to get critical numbers, what must I do? Yeah, set the f prime of x, or the tangent slope, to 0. Because wherever the tangent slope is 0 is where I get max and min points, right? We've discussed that. Also points of inflection. So then we get 4 minus 2x. And we'll subtract our 4, divide by negative 2, and x equals 2. And that's my critical number of the first derivative. So, my critical number of the first derivative, because this is a quadratic, is either a max or a min. Cool thing is, it's a leading coefficient of what? No. It's the leading coefficient of my original. -1. So I know this baby's concave down. So I know that actually at 2 we have a what? Maximum. So I have knowledge, right? So when people tell me minimums, I kind of giggle inside because I was like, you know this is a quadratic that's going downwards. This is not a minimum. Okay, but we have to show algebra because we can't just use that. We can't just be like, because I know this. You have to algebraically show. So how can we algebraically show? We can either do our number lines, which our number line would have a closed dot here, 0, closed dot here, 5, and then we would have a 2. The reason why we have to look at our restricted domain is sometimes, guys, sometimes our restricted domain kicks out the critical number. Like what if this was from 3 to 5? 2 wouldn't even exist. Okay? So you have to watch yourself because sometimes people put critical numbers that don't exist in the domain. All right. We want to check this critical number. What's the fastest way we can check it to see if it's a max or a min?
F double prime.
So f double prime of 2, correct? So what is f double prime? What is f double prime?
Negative 2.
Negative 2. So f double prime is negative 2. So it is a negative. I don't even have to plug something in because it's just negative 2. So if it's a negative, what is this? This is going to be a maximum. Now, how do we know if it's the absolute max or not?
We don't until we check the 2 other inputs.
Yeah, we need to actually get our y values, correct, of all these things. So I need to get f of 0, f of 2, f of 5. Do you see I'm saying f, not f prime or f double prime? Because we're plugging it into the original. Why are we plugging them back into the original? Because you're trying to find the original y values, because you're trying to find the original max and min. Yeah. Okay, so I plug 0 in, I get 12 plus 4 times 0 minus 0 squared. So it's 12. And that's an endpoint. So it can either be an endpoint or an absolute max or min. That's it, right? That's the only options I have. Okay?
6.
Then 2, I get 12 plus 4 times 2 minus 2 squared. Is it 12? It's not true. 12 plus 8 is 16. Okay. Then 12 plus 4 times 5 minus 25. That 5 squared. I don't know why I skipped into the math. This one actually counterbalances itself. So we have 20 minus 25, which is negative 5 plus 12 is 7. Okay. So we technically, if you're stuck, remember we're going to draw something. If you actually have to graph it for them, do we need more than these 3 points? If you actually are asked to graph.
No.
Yes.
Yes, you use as many points as you can. I swear to goodness I taught this. I remember saying it a lot. So if we're just graphing for ourselves to figure out if it's a max or a min or absolute, you can just sketch it off to the side, right? So if I put these points, I would have 0 and 12. 2, 4, 6, 8, 10, 12, 14, 16. Thanks for putting the blue around. So this would be my y scale of 2, x scale of 1 to help myself out, please. Okay, so I have 0 and 12, 2, 4, 6, 8, 10, 12. I have 2 and 16. And then I have 5 and 7. Most accurate graph you've ever seen? No. Does it work? Because I'm not actually submitting this to anyone for mathematics marks? Yes. So, what can you tell me about this graph? Make sure your phones are away, please. It has an absolute max where?
At 2:16.
At 2:16.
Absolute max.
Yeah, that's what I said. And an absolute minimum at what?
I don't know what max. I don't know max.
5. Oh my gosh, I didn't catch it. Yep, I'm now follow. You guys are dorks.
We're literally doing what you asked us to.
It's your notes. I told you could short form in your notes. That was me being
I'm just a bit
kind.
confused because
Practice
down there
what
you
you
said
preach.
maximum and then up there you said max. Which one's which? I don't get it.
Okay, so what about 0 and 12? What is that?
Just an endpoint.
Just an endpoint. Just a good old endpoint, right? Okay. You guys are going to try this one on your own. Just a big gasp. You're going to try this on your own.
No, we didn't learn how to do like stuff.
So we have 2x cubed. So your equation is f of x equals 2x cubed minus 3x squared minus 12x plus 1. And what does that negative 2, 3 mean? Restricted domain. So make sure you have critical numbers first, and make sure then that they actually fit in the restricted domain. So do a number line if you have to. You say it's critical number, but then you say does not exist in the domain, and you don't use it because it would be a coordinate that wouldn't actually get drawn, right? F prime of x equals 2 times 3, which is 6x squared minus 6x minus 12, which I can take a 6 out. I'm left with x squared minus x minus 2. So I get 6, x minus 2, x plus 1. So my critical numbers, I don't know what I'm spelling. My critical numbers are what? Make sure you set it equal to 0. 2 and negative 1. Now guys, I should have had an x equals, sorry. Do those fit in the domain? Both of them do. So, we do a number line. The number line is a closed dot, just square bracket negative 2, closed dot, square bracket 3. And then we have negative 1 and 2. So we go f double prime of negative 1. F double prime, we don't use this reduced one, we use it from here. So f double prime of x equals 12x minus 6. I can take a 6 out if that makes it easier, and I can go 2x minus 1. All right, so I get 6 bracket 2 times negative 1 minus 1. So it's going to be negative 18, which means this is a what? Maximum. Okay, then I have to do f double prime of 2. I get 6, 2 times 2 minus 1, which is 18. Which is positive, which means this is a min. Okay, then what do I have to do? Find the value of f of negative 2, f of negative 1, f of 2, and f of 3. Can anyone tell me what these are? Negative 19, negative 8. Okay, so our endpoints are neither the lowest or the highest, right? Negative 3 and negative 8 actually fall in the middle. Sometimes that's confusing to people, though. So we can do a quick sketch. 2, 4, 6, 8, 10. Let's see. So I'm going to do y scale of 2, x scale of 1. Okay, so I have negative 2 and negative 3. I have negative 1 and 8. 2, 4, 6, 8. I have 2 and negative 19. 2, 4, 6, 8, 10, 12, 14, 15, 18. And 3 and negative 8. So it does something like that. Is that the most accurate graph you've ever seen? No, mine is 4 point. Mine is pointy, which is stupid too. Doesn't really matter because I'm not submitting this as a graph. We agree? So, absolute min. I'm just ignoring you people. So we have an absolute maximum at where? And an absolute min. Now, wouldn't it be nice if we always did polynomials? But such is life, and that's not always the case. So, let's try this one. I'm going to let you attempt it. Now, thinking about it, it is a close. What is it? Oh my goodness. I'm gonna change this to, that doesn't work out to nice asymptotes. We're gonna go like this. I'm not gonna use this one. I'm gonna go minus 2. And I want it from negative 4 to 6. So are things gonna get kicked out?
Yep.
Are there going to be x's that are going to get kicked out?
Maybe.
Yes.
Asymptotes will. So when you factor this, you're going to get x squared plus 2 in the numerator, which is an addition of squares, which results in no critical numbers, correct? Because if I took x squared plus 2, and I said it equals 0, x squared equals negative 2, x equals plus or minus the square root of negative 2, that's not a real thing. You can't take the square root. The other critical numbers come from our denominator, but they are asymptotes, yes?
Yes.
So then there are no maxes or mins. None of those things. No maxes or mins. Then I take my endpoints. I plug them in. One's at like 6 and 0.22222 or something like that, and the other one's really tiny as well. We know this is a rational graph. On each side of the asymptote, what's it doing? Going to infinities and negative infinities, correct? So are those endpoints ever going to be absolute maxes and mins if the graph goes on forever? No. So this doesn't have any absolute max or min. So if they actually ask the question, you'd say there are none. And the endpoints can't be anything but endpoints in this case because the graph keeps going on forever. Once you've done the derivative,
Just giving up.
in
I
the
actually have a great
numerator.
answer.
It's negative x squared minus 2. So you take a negative out.
Wait, negative x squared minus.
So f of x, shh, quiet please, that was an f, guys, f of x equals x square root 4 minus x squared from negative 1 to 2. A little discussion that I would like to have. So our f equation, if this is an f times g equation, we talked about this yesterday, correct?
Yeah.
Our f equation is x. What's the domain of x? The line x.
1, 1, 2, 2, 3, 3.
What's the domain of x?
Positive, negative.
Yeah. It's xer. It's just a line. It goes on for life, right? It's the identity line. So x is xer. So our limiting factor is the square root of 4 minus x squared. Yes? Now, yesterday we had linears underneath. And if you had a linear underneath, you could just say it has to be greater than or equal to whatever it is. Is everyone paying attention? Because you're going to not know why the domain is what it is because you're all writing stuff and doing derivatives right now. You have to find your restricted domain first. This is a what type of quadratic? Take away the root. Take away the root. What type of quadratic is this? Concave up or concave down?
Concave down.
Okay, it's concave down, and I know it has x-intercepts at negative 2 and 2.
Yep.
Right? So the graph is doing something like this if I do a very quick sketch and not accurate because no one's asking me to graph this accurate. Yes?
Sure.
I can only keep the graph where it is what?
2 to negative 2.
2 to negative 2, but why?
Because you can't have negative under your square root.
You can't have negative what's under my square root.
Numbers.
Okay, but this isn't a negative number, so can I just keep that? Why are you stopping it at 2?
But that's definitely a negative number.
Negative what number?
Y.
Negative y values, right? It matters the y's, it doesn't matter the x's, yes? Because whatever gets filled in here is an input of an x, but an output of a y. So I can only keep where whatever that graph is, whatever's underneath there, where that graph has positive y values. So my domain, yes, it's between 1 and 2, but it would originally, even if it wasn't between 1 and 2, it would normally have to be between what? Negative 2 and 2. So we're actually good because it's between 1 and 2, right? But if it didn't have a restricted domain, you would have to restrict it between negative 2 and 2, actually. Get it? Okay, try the question. So we have f, g, f equals x, g prime equals 1/2 4 minus x squared to the negative 1/2 times negative 2x, which gets me negative x 4 minus x squared to the negative 1/2. Okay, so f prime of x equals g, I question my sanity sometimes. G f prime, which is 1 plus f times g prime. What can I take out? 4x squared to the negative.
You forgot the negative.
You did that right.
Oh, wait, no,
I forgot the what?
In the.
I forgot the what?
Zero.
I just canceled them off before I got to here, so I didn't have to cancel them off within the question. Right? Okay. So we're left with 4 minus x squared minus x squared. Guys, minus 2x squared plus 4 over 4 minus x squared to the half. You take a 2 out of the top, negative 2, so I'm left with x squared minus 2, which makes life a little harder. And then 4 minus x squared to the half. So this one here will get me x equals plus or minus square root 2, right? And this one gets me x equals plus or minus 2. We agree?
Sure.
Okay, the catch is, what can I only have? Values between 1 and 2. So square root 2 and the 2 are the ones I get to keep, right? So my critical numbers within the domain are x equals root 2 and 2. Correct? Now, is it easier to find the second derivative of this and then plug in root 2, or would it actually be easier to just do increasing, decreasing? Increasing, and decreasing. So we have, struggle's real sometimes, 1, 2, and root 2, correct? So I plug in something below root 2, which would be, is it 1? 0? Can't plug in 0. I'm at 1 here, guys. So
It's okay saying out of the class only. No, we should play out of the class.
okay. What?
And then see what's the lowest.
Shh.
Instead of like having to do that prime though.
Then, but how do you know it's a max or min?
Because if you have a critical number, so if it goes up, then there's I guess the highest point. Because it would be a concave down.
Are those both a 0? So are they both 0.75?
If f of radical 2 is higher than 2 and 1, it would be a maximum.
Yeah, but you have to prove it. Right? Okay, so we have 1.41. Say I plug in 1.2. And I plug it into here. So I'm going to get negative 2 and then 1.2 squared minus 2 is, so in the first bracket, if I plugged it into here, I get a negative. In the next bracket, I would get a negative, and then in the bottom, I would get 4 minus 1.2 squared, square root of that. Positive. So what do I end up with here? Positive. And then this one I'm going to end up with a negative. I think it's like we put 1.5 in. So we'll get a negative and then 1.5 squared. It's 2.25 minus 2 is a positive. And then on the bottom I'm going to get a positive. So we can't take the square root of a negative. It would make no sense. And so then it's a negative. So I'm increasing to decreasing. So it is a max. And you would explain it that way, right? Like I'm increasing then decreasing. So it's a maximum. So we have to fill in those values. So we have f of 1, f of root 2, and f of 2.
So we don't really care about the 1 or 2 in this case, then? We're trying to find what the value of 1 is and what the major positive.
These are endpoints.
Okay.
Those weren't critical numbers. And even if 2 is a critical number, it's an endpoint. So you have to find what it is. So I plug in 1 and I get 1 square root 4 minus 1 squared. So I get 1 times root 3. So it's just root 3. Then root 2, I'm going to get 1 minus That's just 1 times, not 1 minus 2. Oh my gosh, root 2. And then 4 minus root 2 squared. So it's going to be root 2. Root 2 squared is 2. 4 minus 2 is 2. So it's going to be root 2 times root 2, which is 2 root 2. Two. And then this one is going to be 2. Guys, can you stop talking? It's really hard for me to math when there's constant talking. You're still doing it. So this is going to be 4 minus 4, which is 0. 2 times 0 is 0. So it's root 3, 2, and 0. So is root 3 bigger than 2? What is root 3? 1.73. Blah, blah, blah. Okay, so is root 3 bigger than 2? I repeat myself. You said yes. No, it's 1.73. So we have an absolute max.
So smart.
Plug that into the.
No. I'm finding the values on the original. So we have an absolute max at root 2 and 2, right? And then this is an end point and an end point. I'm not saying they're actually that in the end, I'm just saying that those are endpoints because they're based off of the domain, correct? Endpoints can either be absolutes or nothing. It's an endpoint. So this one is at 1.73, this one is at 0. So the 0 is a what?
Absolutely.
Absolute min. Which is why I don't actually type them out, because they take an entire page. So what I found is I type an equation, like just that little equation, and be like, and then there'd be it's such a waste of printing, photocopying, because it costs at least 10 cents a page, lots of paper. It's easier to get to write it. We're also going to be moving to concavity. When we move to concavity, you're going to have to do the first derivative to get increasing, decreasing, max and mins, and you're going to do the second derivative, do the line to get concavity and deflection. So it takes a page or 2 pages. So that's really not worth it. Team up in one equation. So you tell me all these things. Okay. So you are going to have a couple questions on it. I'm going to post them out of this white book. So I'll post to Google Classroom.